Hey guys, welcome back to your YouTube homework review. The secret word is mirror cube. This guy, which Anthony Roman can solve somehow. I think he's the only one who currently has one. If you haven't figured this out already in these homeworks, the videos are longer, so I would recommend looking at the answer key first, and then watch as much of the video and just the parts of the video that you need to really review everything. Okay. So here's some answers. Alright, 3 divided by negative 5/10. I'm going to use the strategy where I think of this as a ratio, and then I just multiply to get an easier division problem. So I'm going to multiply by 10. 3 times 10 is 30. 5/10 times 10 is just 5, and I'm going to keep the negative. And then 30 divided by 5 is 6, and since I'm dividing and the signs are different, our answer is going to be negative 6. If you didn't want to do it as a decimal problem, you could have rewritten the original problem like this. Because negative 5/10 is the same as negative 1/2. Then you could have multiplied by the inverse of negative 1/2, which is just negative 2, or negative 2 over 1. And then that would equal negative 6 over 1, which again equals negative 6. Alright, I imagine some people at first for number 2 thought that the answer was 6 for this one. And it's not, it's actually 0.6 or 6/10. And let's go over why. So this is regular multiplication, so I can't treat this like a ratio because only division can be thought of that way. So I'm just going to do this like a regular multiplication problem. I'm going to ignore the negative signs for now, and if you do this calculation, you would get these digits. And you might mistakenly think I keep the decimals lined up and therefore I'm supposed to do that. That would be incorrect. A rule that you probably learned in 4th or 5th grade is that you have to look at how many digits are after a decimal point. And since we actually have 2 digits, one for the first number and one for the second number, in your answer, you're going to move the decimal point right there. And since both of the factors were negative, it's going to end up being positive when you multiply that. But one other explanation for why, it helps me just to think of 12 times 5, which is 60. And then I know that if it was 1.2 times 5, what that would do is that would shift the decimal place over 1, and that would give me 6 wholes. And then if we change the 5 to be 0.5, now we'd have to shift the decimal point over again, which would be 0.6. So you can kind of see how all the numbers are related and why it matters that the decimal point is moved over for both of those, because it's going to end up moving it over twice in our answer. So I hope that that maybe made some sense. Alright, so we have a division of fractions problem. Since they're both negative, I know that same signs multiply or divide to a positive, and I'm just going to put a plus sign there to remember that. And now I'm just going to think of it without the signs at all. I'm going to rewrite this by multiplying, or into a multiplication problem by multiplying by the inverse of 3/4, which is 4/3. And then 1 times 4 is 4. 3 times 3 is 9. Since they were both originally negative, my answer turns into a positive, and the answer is 4/9. Number 4 is even easier because it's already multiplication, so I can just multiply across. 1 times 1 is 1. 2 times 4 is 8. And since this is a negative fraction and this is positive, different signs, I'm getting it, it's negative. Numbers 5 and 6 have addition and subtraction, which makes me think of the open number line, so I'm going to model it there. Negative 2/3 plus negative 1/3. So I think back to the lessons that dealt with the flying house from up, and I realized that the first number in an integer problem like this is the starting point of the house. And so we're starting below 0, and we're starting at negative 2/3. We're adding negative 1/3, and when we add a negative, it's the same as subtracting or going down, and we thought about it like adding weight. If you add weight to a house, you're like adding negative to it, and it pulls it down. So if we're at 2/3 below 0, and we add negative 1/3, it basically makes it go down 1/3, and that would get us down to negative 3/3, which is the same as negative 1/2. For number 6, we have 1/2 minus negative 1/4. Again, you can think of that as subtracting weights. And whereas adding weights over here made the house go down because you were making the house heavier, subtracting weight or throwing out weight actually made the house go up. So this is really going to be 1/2 plus 1/4 because it's going to go up 1/4. And before I can add these, I just have to rewrite them so they have the same size parts. So I'm going to make them both into fourths. 1/2 is equivalent to 2/4, plus 1/4 gives us 3/4. And maybe you also thought about it as decimals and got an answer of 75/100. Again, pat yourself on the back if you figured out the state test level fluency. This is where we combine lots of different elements together. So in this expression, to figure out what it equals, I'm going to start off with division. And as a reminder, whenever we're evaluating an expression and there's like lots of different operations to do, we can follow the order of operations. And we're going to start off here with division. This bar means division. So we have 1/2 divided by negative 2/5. And just like we've been doing on this homework, I'm going to multiply by the inverse of negative 2/5, which would be negative 5/2. And then if I multiply across, 1 times 5 is 5, 2 times 2 is 4, and since the signs are different, this is a negative. So I can rewrite this expression as negative 5/4 plus negative 1/4. From there, just like the problems we were just doing, I can think back to the balloon house context, and the starting value is where the house is starting. So since it's negative, we're going to start below 0 at negative 5/4. And then we're adding negative, which is the same as adding weight, which means we're really going down. And we're going down farther away from 0, so it looks like the numbers are getting larger, but really we're dropping down further below 0. And that's why your answer should be negative 6/4. And you should also know that that's equivalent to negative 1/2 and 2/4, which is the same as negative 1 and 1/2. Okay, so doing some percent review, we have this Rubik's Cube online, this pyramid cube, and it has a retail price of $9.50. Amazon charges a processing fee of 10%, which is sort of like a tax, and then after that, plus a shipping fee of $3.95. So first, we can figure out how much 10% is. So the original price is $9.50. If we divide that by 10, the place value is just going to go over 1. So it's going to become 0.950, which we don't really need the 0. So it's basically like 95 cents. And that's 10%. So we're going to treat it like a tax. It's a processing fee and we're going to add 95 cents to the retail price, which should give you $10.45. Then we have a shipping fee, and it even tells us plus a shipping fee, so I know all I have to do is add that. And when you add that, you should end up with $14.40. Alright, and the state test always throws a couple questions like this that have to do with fractions that turn into repeating decimals, that have digits that go on and on and on. So I'm going to change each of these fractions into a decimal. 4 divided by 16, or 4/16, you could do this. And if you were to do that, it would look something like this. But dividing by 16 isn't really fun if you don't have to do it. So 4 divided by 16, we really could have simplified this by dividing by 4, and that would have given us 1/4. And most of you know that, you just have that memorized. 1/4 is the same as 25 hundredths. So that one is not a repeating decimal because it ends. Nothing comes after that 5 hundredths. So not that one. Let's go on to the next one. So we have 2/12. If I want to write that as a decimal, I could go straight to long division. So I'd have 2 divided by 12. And again, since 12 doesn't go into 2, I'm going to add a decimal point and a 0. And then 12 goes in once. 12 times 1 is 12. Since we have a remainder, I'm going to bring down another 0. And then 12 times 6 is 72. And that would give us 8. And I notice that I'm locked into a pattern. Each time we're going to end up with an 8, bring down a 0, and get an 80, which means that this is going to keep on going like this. So already I can kind of stop and realize that this is the fraction that's going to result in a repeating decimal. And you would write it like this, with the bar over the 6 to show that that's the digit that goes on forever. And if you wanted to just check C, 2/10 is easy. 2/10 as a decimal is 2/10. So obviously that one's not going to repeat, so the answer should be B. Thanks for checking your homework, guys. Check you later.